Guideline for modeling with equation. First, you need to identify the variable. Identify the quantity that the problem asks you to find. This quantity can usually be determined by a careful reading of the question that is posted at the end of the problem. Then introduce the notation for the variable, cos x or some other letter. Next, translate from Word to algebra. Read each sentence in the problem again and express all the quantities mentioned in the problem in terms of the variable you define in step 1. To organize this information, it is sometimes helpful to draw a diagram or make a table. So at this point, you may should think about what kind of formulas or what kind of theorem that related to this type of problem. Next, you set up the model. Find the crucial facts in the problem that give a relationship between the expression you listed in step 2. Set up an equation or model that expresses this relationship. Then solve and check your answer, making sure that your answer makes sense and write up your answer in a complete sentence. Let's take a look at a couple examples. Modeling using linear equation. A moving company charged $20 an hour plus an $80 deposit to rent a van. Find an equation that gives the total cost in terms of the number of hours the van is rented. So there are a couple of things that we want. We want to find the total cost. Okay. In terms of the number of hours the van is rented. So we don't know how many hours the van is rented. So first we will start with identify our variable. Let x be the number of hours. Since here we want to find an equation that give the total cost in terms of the number of hours, this means then the equation C of x is the total cost. So what do we know here? We know that a moving company would charge $20 an hour plus an $80 deposit. Okay, so you will be charged $80 deposit and $20 an hour. So C of x equal the charge per hour for how many hours that rent plus the deposit. Okay. So then here C of x equal $20 times the number of hours that rent plus the deposit is the cost to rent the van for X hour. In the next case, a company is selling donuts. They incur a fixed cost of $25,000 for rent, insurance, and other expense. It costs 25 cents to produce each donut. Write a linear model to represent the cost C of the company as the function of X, the number of donuts is produced. So here we were told that X is the number of donuts. So let X be the number of donuts. Then C of X is the cost of producing X donut. Now let's read the problem again. A company sells donuts. they incur a fixed cost of 25,000. What does it mean, a fixed cost of 25,000? It meant it doesn't matter whether the company producing donut or not, they still have to be out 25,000 to begin with. Okay, and it costs 25 cents to produce each donut. And so let's write up the equation. So C the X is equal to the fixed cost. So this is how much it costs. Now this is the additional cost of producing X amount of number unit of donut. Okay, so then we can write this in a complete sentence. C of X equals 0.25X plus 25,000 is the cost of the company as a function of X. Where X is the number of donut. Let me move on to the next type of problem. Here we have area, parameter, and length. So a couple of things that we should talk about: the area, parameter, and length. So what are the common formula that we should know? Well, say we have a square. The area for a square, the square of length A, then equal A squared. The parameter equal 4A. If you have a rectangle with length and width, the area equal length times width. Parameter equal twice the length plus the width. You have a circle with a radius r, then the area equal then the area equal pi r squared. The circumference equal 2 pi r. If you have a triangle with the base and the height, then the area equal 1/2 base times height. Let the length of the side of the triangle are ABC. Then the parameter equal the total of all three sides. So those are the common figure that you should have memorized or have it on hand. Now the area, parameter, and length. Let's take a look at the first example. A poster have a rectangular printed area 100 cm by 140 cm and a blank strip of uniform width around the edge. The parameter of the poster is 1.5 times the perimeter of the printed area. What is the width of the blank strip? So here, looking at this, we can tell that I'm letting X be in the width of the blank strip. Or maybe let it be the width. So let's call it W. So let W be the width of the blank strip. So let's draw the picture here. Let's organize our information in a diagram. A poster have a rectangular printed area 100 cm by 140 cm. So this is the printed area 100 cm by 140 cm, and then a blank strip uniform width around the edge. Okay, so let's draw the edge, and this is a blank strip around it. and the width of this blank strip is W. Okay. So we draw a picture, we label all the information that we have. So it said the parameter of the poster is 1.5 times the parameter of the printed area. This meant that the parameter of the poster is 1.5 times the parameter of the printed area. So let's say, what is the parameter of the poster? The parameter of the poster, the width of the poster is 100 plus 2W. The length of the poster is 140 plus 2W. Okay. So then here we can say, well, the parameter plugged in here of the poster equal twice times 100 plus 2 the width plus 140 plus 2 the width equal 1.5 times the parameter of the printed area. Well, the printed equal to twice 100 plus 140. So multiply with 2 times the sum of 100 plus 140. Let's clean this up. First, I simplify 2 from both sides. 100 plus 140 equal 240 plus 4W equal 1.5 times the sum of 100 plus 240. So 1.5 times 240. Let's solve this equation. Okay. Subtract 242 from both sides. So the width here equal 30 centimeter. Okay. So then we can write up the answer. The width of this blank strip is 30 centimeter. Well, let's take a look at the next example. A woodcutter determined the height of the tree by first measuring the height of a smaller tree that is 120 feet away, then moving so that his eye are in line of sight along the top of the tree, and measure how far it is standing from the small tree. Suppose the small tree is 20 feet tall. The man is 20 feet from the small tree and his eye level is just 5 feet above the ground. How tall is the taller tree? So let H be the height of the taller tree. So let's go ahead and draw this picture. So he wants to determine the height of the tree by first measuring the height of a smaller tree that is 120 feet away. Okay. So let's see here we have a bigger tree. And here we have a smaller tree. And this distance is 125 feet. Then he moves so that his eye in line of sight along the top of the tree and measure how far he's standing from the small tree, and suppose the small tree is 20 feet tall. So the man is 20 feet from the tree, 25 feet from the smaller tree. Say this man, and his line of sight is 5 feet above the ground. So let's go ahead and draw this triangle. Okay. So let's move this a little bit. Note that if I go ahead and draw the straight line from line of sight of where the man is standing to the taller tree, I get similar triangle. The first one that highlighted in red, so I get a larger triangle. Okay. And this triangle is similar to this green small triangle. Now, if the line of sight of the man is 5 feet above the ground, then to measure the length of the small green triangle, this side here has to be 15 feet. Okay. And the horizontal distance from the man to the small tree still 25 feet. Now, I can set up the proportion to the similar triangle as follow. I can say that, hang on, I forgot to label where is the height of the taller tree, right? So here's the height of the taller tree. So he's 8. This whole distance is the taller tree. But in this red triangle, this distance here has to be 8 minus 5. Okay. So let's draw the two triangles out individually and label it accordingly. So this one has the length of 8 minus 5. If you look at the length of the red triangle, that is the distance from the taller tree to where the man is standing. So that is 125 plus 25 feet. So this distance is 150. In the smaller triangle, we have 15 feet. The distance from the smaller tree to the man is 25 feet. I can set up this proportion at 8 minus 5 over 150 is equal to 15 over 25. I will multiply both sides by 25. So then 8 minus 5 times 25, and I multiply both sides by 150. 15 times 150. I can go ahead and solve this equation for the height of the tree. So 25/8 minus 125 equal divide both sides by 25. So then the height of the taller tree is 95 feet. The next tab we want to talk about is work done. So here we have a formula. It says a fraction done by A plus a fraction done by B equal a fraction done by both. What does this really mean? It means when you solve a problem that involves determining how long it takes several workers to complete a job, we use the fact that if a person or machine take T time unit to complete the task, then in one time unit, the fraction of the task have been complete is 1 over T. So for example, if Johnny take 4 hours to complete painting a wall, then in 1 hour, he got a fourth of the walls painted. Okay. So let's take a look at the first example. Candy and Tim share a paper route. It takes Candy 70 minutes to deliver all the paper, and it takes Tim 80 minutes. How long does it take for the two to work together? Well, we don't know how long it takes for the two to work together, so we go ahead and let T be the time it takes for them to work together to complete the job together. So here, in 1 minute, Candy finished 1/70 of a job. In 1 minute, Candy finished 1/70 of the job. In 1 minute, Tim finished 1/80 of a job. So working together in 1 minute, they complete 1T of the job. So let's go ahead and add the fraction on the left side. So first we need to figure out what is our least common denominator. Yes, so the least common denominator, we will clear the fraction, that is 5/60 T. I will multiply each of the term by the least common denominator. And simplify. So I get 80T plus 70T equal 5/60. So 150T equal 560. So T equal 560 divided by 150. So simplify this fraction. 55 over 6, 15. So this is about 3 minutes and 3.73 minutes. Yes, so let's double check. Candy takes 70 minutes to deliver all the paper. It takes him 80 minutes, but together it only take them 3 minutes. So this does not make sense, right? So let's see where did we make a mistake in our calculation. Well, let's check. Well, in 1 minute, Candy finished 170 of the job. Tim finished 180 of a job. Together, they finished 1T of the job. The least common denominator for this equation is 560T. The mistake comes in when we make the simplification. 70 go into 650T 8 times. So this equation need to say 8T plus 7T equal 560. So 15T equal 560 and T equal 560 divided by 15. So this is about 37.3 minutes. Okay. So this makes a lot more sense, right? If Candy takes 70 minutes and Tim takes 80 minutes, together they take on average about 37 minutes to get the job done. So then the answer, it takes 37.3 minutes for them to complete the job together. Next problem. Betty and Karen have been hired to paint a house in a new development. Working together, they can paint the house in 2/3 the time it takes Karen working alone. So that sounds pretty important. So let's underline that. They paint the house in 2/3 the time. So together, they paint the house in 2/3 the time it takes Karen working alone. Betty takes 6 hours to paint the house alone. How long does it take Karen to paint the house working alone? We don't know how long it takes Karen to paint the house. So we go ahead and let T be the amount of time it takes for Karen to paint the house alone. Okay, so back to the thing that we highlighted. Together, they can paint the house in 2/3 the time that take Karen working alone. So this meant, so then together, they paint the house. So together, they take 2/3 the amount of time, hour, to paint the house. Now I can set up my equation. Well, working alone, it takes Betty 1/6 of an hour. Working alone, it takes Karen 1/10 of an hour. Together, it takes them 1/2/3 T amount of time to finish the job together. Let's clean up this equation. I can rewrite this as 1/6 plus 1T equal 3/2T. Okay. Now, what is the least common denominator? The least common denominator here equals 6T. I can multiply each of the term by the least common denominator. So T plus sit equal 9. So T equal 3. So it takes Karen 3 hours to complete the job. To paint the house alone.